So in the last video, we left off at this free body diagram, and so I explained that this mass, which is hanging from a spring and dashpot from a rigid constraint. Um, so we are looking at this mass in isolation, and the forces that apply to this mass is the force of gravity, and the spring force and the dashpot force. So according to Newton's second law, the sum total of all these forces should equal to the total force applied to this body, which equals to the mass of this body times the acceleration. So this acceleration you can write as a derivative of velocity. So if x is the position, then dx dt is the velocity, and the second derivative of x with t is the acceleration. So the total force is equals to mass times acceleration is equal to the sum of these forces. So if you rewrite this, then you'll get mass times acceleration plus eta times velocity plus k times x equals to minus mz. So this equation is called a single degree of freedom second order non-homogeneous ordinary differential equation. So I just want to ask a question whether you are familiar with all these terms, and so you should be able to tell why it's called a single degree of freedom and why it's second order, why it's not homogeneous, and why it's ordinary differential equation. So solution of this equation can be done analytically. That is, you can sit down with a pen and paper, and due to the invention of calculus, you can apply calculus and solve this equation and come up with an equation for x with respect to time given all these other variables: mass, acceleration due to gravity, k, the spring constant, and the so the dashpot constant is called a damping coefficient. So, and the damping coefficient. But turns out that equation is pretty complicated. It's not too complicated, but it can be complicated if the number of mass, if you increase some of this, for example, if you go from second order to third order, or if you have, instead of constant gravity, if you have a variable force, or which is often the case, or if you have, instead of a single degree of freedom, if you have hundreds of degrees of freedom, then it becomes more and more difficult to solve this on pen and paper. So eventually, you would solve it using a computer these days. So for my next section of this lecture, I'll talk about installing Python so that you can solve this equation in Python.